Okay, hello everyone. I welcomes to all in our lecture series on Dirac delta function. In this lecture series, we are discussing these topics, which are essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our last three classes, we have been discussed in detail about introduction to Dirac delta function, representation of Dirac delta function by various functions, properties of Dirac delta function. Up to sixth property, we have been discussed along with important questions based upon these properties. In today's lecture, we are going to discuss seventh property and its corresponding numerical. Okay, so let us start. These things we have been discussed in our previous lectures. Introduction part, representation of Dirac delta function, application of Dirac delta function, properties. Up to sixth property we discussed. Okay, these are third property, fourth, and this is your fifth, then sixth property, and we discussed important questions. Now we are going to start to discuss property number 7. Here delta Ax equal to 1 by A mod delta x. Okay, this we have to prove. Here proof starts. Consider a continuous function fx and multiply with above equation, then integrate both the side from minus infinity to plus infinity with respect to x. So this is your equation. We have to multiply fx and integrate with respect to x. Limit is your minus to plus infinity. Here that implies left hand side I am telling fx delta ax dx integration minus infinity to plus infinity. Right hand side also we have to write like this, minus infinity plus infinity limit fx, this one 1 by a mod delta x dx. Here 1 by a mod is a constant taken outside of the integration, minus infinity to plus infinity fx delta x dx. Okay, now we are going to use the fourth property on RHS. Now the above equation will be LHS as such I written over here. The RHS will be 1 by a mod, and this integration value will be f of 0 according to fourth property. Here also I written fx delta x dx equal to f of 0 according to fourth property. So here this value will be f of 0. Let this is your equation number 1. Now consider LHS of equation number 1 here. Okay, first we are going to consider the A is your positive quantity, and here A can be a number or a fraction itself, can be 2 3 like this, 2 3 4, 1 by 2, 1 by 5 like this. First in our case 1 we have to prove by considering A is your positive value, that may be number and or fraction. Okay, so minus infinity to plus infinity fx delta ax dx. For this integration, put t equal to ax, dt will be equal to ax, dx will be dt by a. Now we are going to check the new limit. For x equal to infinite plus infinite, t will be plus infinite. Here if I will be consider x equal to infinite, obviously a infinite means it will be infinite, t also infinite. If x will be minus infinite, here if I am going to consider minus infinite, also t will be minus infinite. Okay, now we are going to substitute these values in this integral, then it will be minus infinite to plus infinite. Instead of x it will be written as t by a, delta ax is nothing but t. Okay, dx is nothing but dt by a. Okay, so here you can see 1 by a is a constant. Okay, this 1 by a can be taken outside. Here minus infinity to plus infinity is there, f of t by a delta t dt, right? This integral value will be f of 0, because according to fourth property we know minus infinite to plus infinite fx delta x equal to f of 0. If I am going to apply the fourth property over here, it will be how much? 1 by a, f of 0 by a is nothing but f of 0, right? So this integral value will be 1 by a f of 0. Again, I am going to apply the fourth property. Instead of f of 0, we can write minus infinity to infinity f of x delta x dx, no problem. Now you just compare LHS and RHS. fx common term for LHS and RHS, common function integrated with x, limits are also same. So if LHS will be equal to RHS, that means this value delta AX should be equal to 1 by a delta x. So that implies delta AX will be equal to 1 by a delta x. Let this is your equation number 2. We found this result by considering a greater than 0. That means a we considered positive. Now we are going to consider a negative value, a less than 0. What will be the equation number 1? Okay, now we are going to put this a as a negative in your equation number 1, LHS of equation number 1. Here case 2 for a less than 0, then LHS of, here you have to write, I will write at the time of uploading this note, the LHS of equation 1 will be minus infinity to plus infinity f of x is there. Here instead of plus a, we have to write minus a x dx as a less than 0. Put t equal to ax, dt will be minus a dx, dx will be minus dt by a. Now we are going to just check the new limits. For x equal to positive infinite, if I will put over here, then t will be minus infinite. Okay, if I will put x is your minus infinite, so here minus is there, so t, for t the limit will be plus infinite. So the new limits we found here, plus infinity to minus infinity. This is your lower limit, will be lower limit and upper limit, the new limits. So initially the limits were minus infinity to plus infinity. Now it will be plus to minus infinite. Now we are going to substitute the values over here. Instead of x, here t equal to minus ax, so obviously x will be minus t by a. I substituted over here. Minus ax is your t, dx here minus dt by a, right. 1 by a, here 1 by a is there, taken outside of this integration. Now this minus, when it will interact this integration limits, the integration limits will be just exchanged. Okay, the upper will be lower, lower will be upper limit. So the when the minus will be interacted with this integration, the limits will be minus to plus infinite f of t minus a delta t, this will be dt. 1 by a already I have been taken. Here you can see this value, this integration value will be f of a, because by using fourth property we know what fx delta x minus 0 or delta x equal to f of 0, right. Here delta t means delta t minus a is there. The value will be how much? Value will be f of minus 0 by a, is nothing but f of 0 itself. So this value will be f of 0, 1 by a is there, 1 by a. Now again I am going to apply the fourth property for f of 0. Instead of f of 0, we can write integration minus infinity to plus infinity fx delta x or delta x minus 0 dx. Same thing I have been written. So here we found minus infinity to plus infinity fx delta minus ax dx equal to 1 by a minus infinity to plus infinity fx delta x dx. See, we considered this integral and we found this one. That means both are same. If both are same, if this equal to this one, here you can see fx and fx both are common, integration limits are also same, integrated with respect to x. So here we can conclude, if this LHS equal to RHS, that means delta minus ax has to equal to 1 by a delta x. Okay, let this is your equation number 3. This equation number 3 we found for a less than 0. Right? Right. Now just compare equation number 2 with equation number 3. By comparing 2 and 3, here you can see delta Ax we found 1 by A delta x, delta minus Ax also we found 1 by A delta x. So in general we can write delta x Ax Ax equal to 1 by A mod delta x. So here A can be considered as positive or can be considered as negative, no problem. Okay. Okay, here we prove this property itself. Okay, and one interesting thing you can observe here, that from this, by using this property we can easily prove that a delta function is a even function. Here you can see by substituting A equal to 1, if I am going to consider A equal to 1, I am going to consider the seventh property, that means delta x will be equal to 1 by 1 mod delta x. Okay, if I am going to consider A equal to minus 1, A minus x, sorry, delta minus x will be equal to 1 by minus 1 mod delta x. That means delta minus x will be equal to delta x. So by using this property, easily we can observe the even function or even function property of the delta function. Okay. Now we are going to go for numerical based upon property number 7. Here first question, find the value minus infinity to plus infinity a square plus cos x delta minus pi x dx. What will be the value? Solution here starts from property 7. What we know, delta ax equal to 1 by a mod delta x. So here delta, here first we are going to calculate this value. Delta minus pi x value will be 1 by minus pi mod delta x. The mod function always it will be positive, so 1 by pi delta x. By using property number 7 we found this one, so we have to put this value. Okay, so if I will put, instead of delta minus pi x equal to this one, the 1 by pi I taken outside of the integration, minus pi to pi, x square plus cos x is there, and delta x we can write delta x minus 0. Okay, so the value will be here, the value will be here written. Then we have to use the property number 4. Fx delta x minus a is your f of a. So here if I am going to compare this integration with this integral, here a value is your 0, fx is your this one. So instead of x we have to put 0 value. So 1 by pi is there. Okay, so if I will put 0 instead of x 0, then it will be 0. Cos x instead of x 0, if I will put cos 0, cos 0 value is your 1. So finally we can get the answer will be 1 by pi. Now we are going to go for second question. Find the value of this one, minus 1 to plus 1 5x cube delta 2x plus 1. Okay, here solution starts minus 1 to plus 1 5x cube delta 2x plus 1. 2x plus 1 can be written as, here if I will take common 2 from these two terms, it will be x plus 1 by 2. Okay, here x 2 into x plus 1 by 2. Now we are going to apply the seventh property. Seventh property is nothing but delta ax equal to 1 by a delta x. Here you can see delta, this is in the form of delta ax. A is nothing but a and x is nothing but this one. Okay, okay, so this value will be how much? 1 by 2 mod and delta this much, x plus 1 by 2. Got it? Dx. Now 2 mod is your 2, 5 is the constant, 5 by 2 I taken outside of this integration, minus 1 to plus 1, x cube is there, x cube delta x plus 1 by 2 dx. Right, now we are going to apply the fourth property on this integral. According to fourth property, we know fx delta x minus a dx equal to f of a. So by comparing these two integrals, here fx is nothing but your x cube, right? And a value is nothing but 1 by 2, sorry, minus 1 by 2, because this can be written as delta x minus of minus 1 by 2, right? So here a is nothing but your minus 1 by 2. So the answer will be f of minus 1 by 2, or fx is nothing but x cube, so it will be minus 1 by 2 whole cube, right? Same thing I have been written directly by using property number 4. This integral value will be minus 1 by 2 whole cube. So this value will be, here you can see, minus 1 by 2, minus 1 to the power 3 is itself minus 1, and numerator will be 5, and denominator will be 2 to the power 4, means 16. The answer will be minus 5 by 16, right? Right. Here I am going to stop this lecture. In our next lecture, we are going to discuss property number 8 and corresponding numericals. Thank you so much for watching this video. Thank you.